Hello everyone. Today I'm going to give a brief introduction to GeoPandas library in Python. Here are my contents today. Firstly, I will introduce some basic concepts of GeoPandas. Then I will show how to install it. Furthermore, I will introduce some functions of GeoPandas. And last but not least, we can try making a COVID world map with the help of GeoPandas. So, first of all, what is GeoPandas? As the name suggests, GeoPandas extends the popular data science library Pandas by adding support for geospatial data. GeoPandas can simplify the processes of geospatial data, which can help users not so reliable to ArcGIS, PostGIS, etc. too. There are two kinds of core data structures in GeoPandas. The GeoPandas GeoData frame is a subclass of Pandas data frame that can store geometry columns and perform spatial operations. The GeoPandas GeoSeries is a subclass of Pandas series that handles the geometries. As you can see, the GeoData frame is a combination of Pandas series, with traditional data, the yellow part, and GeoPandas GeoSeries with geometries, the pink part. Then I will show you how to install GeoPandas library. Because GeoPandas depends on many other libraries, we can't just simply import GeoPandas to install it in Python. The first solution is to install with Conda Package Manager, which is recommended by the official website, and here's the link. The advantage of using the Conda Package Manager is that it provides pre-built binaries for all the required and optional dependencies of GeoPandas, for all platforms including Windows, Mac, and Linux. You can open the Anaconda prompt and input Conda install GeoPandas. Then the GeoPandas will be installed automatically. Or you can input Conda install channel Conda Forage GeoPandas, which is supported by Conda Forage channel. Conda Forage is a community effort that provides Conda packages for a wide range of software. It provides the Conda Forage package channel for Conda from which packages can be installed, in addition to the default channel provided by Anaconda. Depending on what other packages you are working with, the default channel or Conda Forage channel may be better for your needs. For example, some packages are available on Conda Forage and not on defaults. But what if you fail to install GeoPandas with Conda? Well, so did I. I will strongly recommend you to try the second solution. Firstly, you should go to unofficial Windows binaries for Python extension packages and download the following binaries. And there are many versions of each binary. You'd better manage to download the correct file for your computer. CP is your Python version and Win32 or 64 is your computer bit. What you should notice is that you should clarify the Python version. For example, your computer Python software version and your Jupyter Notebook Python version is not the same. And one more thing you should know is that all the extension packages should be put in the specific folder, strips folder, which is a subfolder of Anaconda. Then you can open your Anaconda prompt and install them one by one. Finally, whatever above solution you choose, you can import GeoPandas in Python to verify whether you installed it successfully or not. After installing GeoPandas, let's see what it can do for us. The most important thing is how it can read and write files. Assuming you have a file containing both data and geometry, such as shapefile, you can read it using GeoPandas read file, which automatically detects the file type and creates a geodata frame. And LIBB here is the map of New York boroughs, which is part of the GeoPandas installation. Therefore, we use GeoPandas dataset getPath to retrieve the path to the dataset. Then, if you want to write a geodata frame back to file, you can use geodata to file. The default file format is shapefile, but you can specify your own with the driver keyword. There are several simple and useful accessors and methods. Firstly, GeoPandas can measure the area of each polygon easily by accessing the geodata area attribute, which returns a pandas series. To make the results easier to read, we can set the names of the borrows as the index. Then we access the geodata area attribute. Now we can see every borrow area. What's more, if you want to get the boundary of each polygon, you can access the geodata boundary. We can also create new geometries, which could be, for example, a buffered version of the original one, such as geodata buffer 10 or its centroid. Furthermore, we can measure how far each centroid is from the first centroid location. Or we can access the distance column and call the min method on it to calculate the average of distances measured above. Because GeoPanda geodata is a subclass of pandas data frame, all the pandas functionality is also available on the geospatial dataset. GeoPandas can also plot maps, so we can check how the geometries appear in space. We can use geodata plot to plot the active geometry column and color code by the area column with a legend. And we can also explore the data interactively using geodata explore, which behaves in the same way as function plot does, but returns an interactive map instead. Switching the active geometry to centroids, we can plot the same data using point geometry, and we can also layer both geoseries on top of each other. We just need to use one plot as an access for the other. Now we set the active geometry back to the original geoseries. What's more, we can further work with the geometry and create new shapes based on those we already have. If we are interested in the convex hull of our polygons, we can access geodata convex hull. In other cases, we may need to buffer the geometry using geodata buffer. Geometry methods are automatically applied to the active geometry, but we can apply them directly to any geoseries as well. Let's buffer the borrows and their centroids and plot both on top of each other. Using the geometries above, we can check which of the buffered borrows intersect the original geometry of Buckland. Let's say is within 10,000 feet from Buckland. Firstly, we get a polygon of Buckland. The polygon is a shapely geometry object, as any other geometry used in GeoPandas. Then we can check which of the geometries in GeoPanda data frame buffered intersect it. Only Bronx on the north is more than 10,000 feet away from Buckland. All the others are closer and intersect our polygon. Alternatively, we can check which buffered centroids are entirely within the original Burrows polygons. In this case, both geoseries are aligned and the check is performed for each row. We can plot the results from the map to confirm the finding. Last but not least, let's talk about projections. Each geoseries has its Coordinate Reference System, CRS for short, accessible at geoseries.crs. The CRS tells GeoPandas where the coordinates of the geometries are located on the Earth's surface. In some cases, the CRS is geographic, which means that the coordinates are in latitude and longitude. In those cases, its CRS is WGS84, with the authority code EPSG 4326. Let's see the projection of our New York borough's geodata frame. Geometries are in EPSG 2263 with coordinates in feet. We can easily reproject a geoseries to another CRS, like EPSG 4326, using function geoseries to CRS. For the final part, I would like to share a project that how to make a COVID world map with GeoPandas. And this case may take about 40 minutes. So I put the YouTube link here. If you are interested in applying GeoPandas in practice, I strongly recommend you to watch this video. Okay, that's all I want to share. Thank you for your attention.